Hey all, it's Mrs. Conway. So, I wanted to have a way for online students and students who've missed class to know whether they've done their packet right. So, for Unit 4 packet, we're not done with it, and I don't know that we will finish it. So, what I've done so far is what I want everybody to have done. Anything after that is sort of optional extra practice. So for here, these are vocabulary words. I do want you to go ahead and either look them up or look at the PowerPoint that's posted on Teams for the definitions. I really didn't want to rewrite them. They're typed up on Teams. And if you want to do some more research and see some other definitions, you can. Same thing here with this. I didn't make a key for this, but just some sort of ideas. The definition function, a relation where each input has exactly one output. Can look that up. Characteristics of a function. What I was aiming for here is we already defined relation as being a set of coordinate pairs. So remember that could be related as a table, a set of points. It could be an equation. It could be a graph. It could even be a sentence. So there's lots of ways to represent a function. So, maybe draw yourself some pictures. When I say table, I mean like X, Y. Okay, so just some things about functions there. Whatever you think of when you think of a function. Maybe you just draw a graph. So, and then for examples and non-examples, really when you work through the Delta Math assignment for lesson 1, that would be a good way to gather some examples and non-examples. So I'm not going to go over this. I want you to use Delta Math to make some notes in here. And then the last one, though, is just of an equation because there isn't really much of that in Delta Math. So you might put like a set of points, one of those input-output table thingies. You can get those from Delta. But an example of an equation that is a function would be like any linear function that's not a vertical line. So like y equals x. Something that's not a function, like y equals the square root of x, because when you square root a number, it could be negative or positive. So any input would have two outputs, so that's not a function. So hopefully use Delta Math to fill these in. I don't want to do your work for you, but take a look. Delta Math, fill this in. Okay, task 3, rate of change. A lot of this was a conversation. But some ways to see rate of change here. It says, explain how the rate of change can be seen in the written scenario, on the graph, or in the table. So in the scenario, it's how much she is charged per kilowatt hour. Right? Because the $20 per month, she just pays that one time per month. And we know that our rate of change is the kilowatts per hour. Because this doesn't change every month. It stays the same every month, but this does. Okay? In the table, we might see rate of change 2 different ways. This is a direct proportion, so you could just do, oh no, it's not a direct proportion. But someone said is, okay, well, we know it's $20 per month, take that off, then divide it by your input. That'll tell us our rate of change. Or you might say, okay, it goes up by 100. And it goes up by 15. 15 over 100 is 15 cents. In the table, in the graph, you should be seeing the slope, rise over run. Okay, so those are how you're going to see those rates of change. In the peaches plums scenario, which one has more cost per pound? Hopefully you said peaches because it's got a steeper slope. And then bananas, as long as this line has got a shallower slope than plums, you did it right. Okay, this is probably the one that might need the most editing. So here's what we got. For number 1, independent is number of days or number of hours, some sort of time. It doesn't actually say, just height of the grass in the yard over the summer. Dependent, height of the grass. 2, number of buses is dependent students, so independent students, dependent buses. 3, independent, weight of the dog, dependent, reading on the scale. 4, independent is distance between departure and destination. Dependent is time on an airplane. 5, independent, number of times you dip the candle. Dependent is the diameter of the candle. Independent for 6 is the number of days overdue. Dependent is your amount you owe the library. Ooh, sorry, I said that and then didn't show it. I really should have wrote longer sentences here. You are the student, so please do. Like, that's what you should be writing, the parts that I put brackets on. I'm going to go fast. You can always go back and pause if you need to. Okay, number 7, independent, number of homeworks missing. Dependent, grade. 8, independent is time. Dependent is temperature. 9, independent, weight. Dependent, length. 10, independent, diameter. Dependent, cost. 11, independent is number of cars, and dependent is the exhaust, fumes in the air. Okay, so practice with independent versus dependent variable. Remember, independent is the one that changes the... Okay, task 6, coffee by the pound. Some things to clear up. You're not buying anything else. Coffee, they all cost the same amount. So what is the cost per pound for this coffee? Take your cost for 3 pounds, divide it by 3 pounds. That gives me $6.32 per pound. What about how much we could buy for $1? A couple ways to think about that. One, well, it's $6.32 per pound. So if I want to know how much it costs for $1, I just do 1 divided by 6.32. Or some people thought of it more as like, okay, well, if it's 3 pounds of coffee for $18.96, 3 divided by 18.96. Either way, you end up with 0.16. Okay? We decided that based on how we would think of this as you're going to the store and you're buying coffee, so independent would be pounds of coffee and dependent would be cost. Now, if you were asking question B, it would be the other way around. So we graphed this with pounds of coffee. On the x-axis, we went by ones. Cost, we went by fives. On the y-axis, it ends up being linear, and it goes through 0, 0, because 0 pounds of coffee would cost $0. And so the slope is the cost per pound of coffee. All right, number 7. Kelly is working at an after-school program. Now we're comparing this table to Marin's $7 per hour. So it says who would make more money for 10 hours. So we thought, okay, well, Kelly, from 1.5 to 2.5 hours, the pay goes up by $8.40. So Kelly is making $8.40 per hour, times 10 would be $84. And Marin's making $7 an hour, so $70. So Kelly obviously would have more money. So we just drew a quick sketch here. We're like, okay, well, we know Kelly makes more, so Kelly's graph is steeper than Marin's. They both make $0 for 0 hours, so it starts at 0, 0. And then I just kind of vaguely plotted, like, I know Kelly at 4 hours has $33, and Marin, I did 4 hours is 28. So I just went from 0 to 28 and 0 to 33. And so how would we know who makes more? Well, Kelly's graph is steeper, so Kelly makes more per hour. That's that last question at the bottom. Okay, now we're back to coffee. Same coffee problem. Plot these points. So we did, went by ones on the x-axis, went by twos on the y-axis, plot our points, and then it says make slope triangles. So talking about these stair-steppy thingies. So we're like, okay, what does that have to do with coffee by the pound? Well, these points represent buying 1, 2, and 3 pounds of coffee. And then the triangles, it turns out, these two are exactly the same, which means that since we're going up by 1, since each triangle represents an increase of 1 pound of coffee, the fact that they're congruent would show that this is linear, because that means our rate of change is constant, which is what a linear function is. It's a constant rate of change. So I think this is the last problem that we're going to do in the packet. It says Megan's Disney vacation. So discuss the following. What's the meaning of the slope? What's the meaning of the independent and dependent variables, the intercepts, domain, and range? So the intercepts in this problem are 10.5 and 685, which makes sense because they start at 685 miles away, and then it should take them 10.5 hours to get to Disneyland. So the slope would be their speed, the 65 miles per hour. The independent and dependent variables, independent is number of hours traveled, dependent is remaining distance. For those of you who are online, you probably haven't seen these cards that I like to use to remind myself about domain and range and independent and dependent. So domain goes with X, it's independent, it's horizontal. Range is dependent, Y-axis vertical. So you might want to write that down in your notes really quick. You can hit pause. So in this situation, the range is going to be any number from 0 to 685 because the only thing, like the distances aren't going to be more than that or less than 0. Domain is between 0 and 10.5 because you're not going. You could put 11 if you wanted, if you weren't sure, but 0 to 11. So that is basically what we've done so far in the packet. The rest of the packet, if you want to take a look at it, is good practice. But I'm not at this point planning on going over them. I think that the Delta math that I've assigned is sufficient to give you the practice that you're going to need to pass the test. So hopefully you got all those right, and by now they should definitely be right. So if you want to work on the rest of the packet and you want solutions for that, let me know.